let's take a few minutes here and talk about how we're going to measure in a science setting. So science is all about collecting data and trying to do something with that data. In order for us to all kind of be on the same page and collect data consistently, there's one really unified method that pretty much everybody uses to do data collection. And that system involves two types of digits. We have certain digits and estimated digits. So as we collect data and we get a number, every number will have so many certain digits, and you'll see in a second one estimated digit. So now a certain digit is going to be a digit that is 100% known to you. And how it will be 100% known to you is by measuring something with a certain type of measuring device or measuring instrument. For example, we're going to use this kind of fake ruler over here to the left in a second. This is a ruler that's going from 0 centimeters up to 3 centimeters, actually up to 3.2 centimeters. And every small mark here is 0.1 centimeters. Any number, any digit that you generate using your device is a certain digit. And it's going to be important to collect all of the certain digits that you can from your device when measuring. In addition to that certain digit, we have an estimated digit. An estimated digit is less than 100% known, right? This is really something that we're kind of, for lack of a better word, guessing on. We're taking our best guess at what we think that measurement is. How accurate that estimated digit, how reliable it is kind of dependent upon the device that you have. So if you have a very strong, very good measuring device, this estimated digit will probably be better than if you have kind of a weak measuring device. The big thing about estimated digits here is that you only collect one estimated digit. So let's look at a little bit of an example here. So I have my ruler, and let's say somewhere on my ruler, I'm using my ruler to measure a line. And I'm going to measure this kind of blue line here that I've just drawn in. So I started at about 0, and this blue line comes all the way up here. And let's actually just draw it up. If we draw it up, we can kind of see where it ends a little bit better on the ruler. So I'm going to use that ruler to measure this line. So I want to make sure that I collect all of my certain digits, right? That was one of our big points here. We need to take every digit that we know 100% about this line from our measuring device. So my blue line starts at 0, and you can see that it clearly goes past 1 up to 1.5, and it actually goes clearly past 1.5 by just a little bit, right? Every little marker here is 0.1, sorry. So that means that this kind of slightly larger one is 1.5 centimeters. So my measuring device here can tell me two digits 100%. It can tell me the 1 because I'm clearly past 1, and it can tell me the 0.5 because I am clearly past 0.5. So those are my two certain digits in this measurement. 1 and 0.5 are both certain. Now, we talked about this a second ago. In addition to our certain digits, we need an estimated digit. We need just a single estimated digit. We could actually even change my little list over here on the side, not to just say one estimated digit, but one more estimated digit. So what I mean by that is if we're going to estimate a digit, let's estimate the smallest digit, not the biggest one, right? So 1.5 are certain measurements. We need to estimate one more digit. So what that means is that this line is clearly beyond 1.5, but it's also clearly not, change color, not up to 1.6, right? It's clearly in between kind of these two yellow bars, past 1.5, but not up to 1.6. That would be the next digit in my number. So that's the digit I want to estimate. I want to look between 1.5 and 1.6 here in this yellow range and estimate about where I think my blue line falls, and I'm going to say 0.04. So this 0.04 would be my next digit. So that yellow digit now is considered to be an estimated one.